welcome to Composite Figure Notes. You're going to have a couple different pages where we take notes for composite figures. The definition for composite figures is going to be shapes that have two, hang on a second, let me try move it up a little bit, two or more figures. Okay, so shapes that have two or more figures are called composite figures. This is what we say are mashups. Composite figures are mashups of our basic shapes. So some illustrations could be a rectangle mashed up with another rectangle. And the only thing is you would, oh, that's too big. Let me put some lines in here. You wouldn't know, you wouldn't have it divided for you, so it would look like this. That would be one. Another kind would be if we had a triangle. That's an upside down triangle. Let's try that one again. Let's erase that bad boy. So if we had a triangle, and we put that, we mash that with a rectangle. Okay, if we did something like that, and then if we took out this line here in between, then this would be your mashup right here. And you could draw the line in here to separate the two. And that's what we're going to get to when we want to solve things. You could also have circles mashed up. You know, if I wanted to mash up, let's see, a circle with a rectangle. We could mash those two up. And again, you wouldn't have this part right here. This would all be gone. It would kind of look like this, like an ice cream cone or something. You could have a mashup of a circle and a rectangle. So these are illustrations, just pictures of different types of composite figures. So examples would be pretty much any combination of two or more shapes. So we could write, we could have two rectangles. That would be a mashup. We could have a triangle and rectangle. Miss Walker could spell. There we go. And then the third one that we drew above would be a circle and a rectangle. Now there are many types of mashups, and it doesn't just have to be two. You could have a triangle with a circle, with a rectangle. I mean, you could have all different kinds of composite figures. It's going to be two or more basic shapes that they have put together in some design. Non-examples, so things that are not composite figures, are going to be your basic shapes. Your rectangles, you could have a square, you could have a circle, you could have a triangle. Any basic shape, and that includes parallelograms and trapezoids. And yep, they can be upside down, it doesn't matter. But these are non-examples. So again, in this, what we call a Freyer model for notes, we have our definition, shapes that have two or more figures. Okay, so two or more basic shapes that are mashed together. We have some pictures of what it could look like. We have some word examples, two rectangles, a triangle and a rectangle, etc. And then our non-examples are going to be just basic shapes that are by themselves. These are not composite figures. These are called basic figures or basic shapes. Okay, so pause the video, write this down, fill it out, and we'll move to our next sheet. Okay, here's our next sheet. We're going to fill out some words that you need to know, and then we'll do some examples of what it's going to look like. So number 1, a blank figure is made up of triangles, squares, rectangles, and other two-dimensional figures. And the word here is going to be a composite figure. Okay, so composite figures are made up of 2 or more two-dimensional figures. Rectangles, triangles, circles, squares, any two-dimensional figure. A composite figure is not a standard basic shape. Okay, it's not just a triangle. It's not just a circle. It's got to be more than that. It's got to be two things put together. To find the area of a composite figure, blank it into figures with areas you know how to find. So this is, you could write separate. I'm going to use the word divide. You're going to break it down into the shapes you know. That's the easiest way to figure out area. Perimeter is pretty easy. Again, perimeter is the same thing. You just have more sides. But when it comes to finding out the area, that's a little bit more involved. You got to break it down into multiple basic shapes. Then you find the blank of the areas of those figures. So this is sum. So then you find the sum, and that means the addition. So if I broke this down into, let's say, 3 rectangles, I would find the area of each and then add them together. So you would have to break it down, then find the sum. All right, number 5 says separate the composite figures below into basic shapes that you can find the area of. Label each shape and write the formula that you would use to find that area. So we're not going to label rectangles and stuff. I believe you guys know that, but we will write the area formula. So multiple ways you could break this down. I could break it into a rectangle at the top and at the bottom. I could do 2 side rectangles. I wouldn't break down all 4, right? So 1, 2, 3, 4, and then 5, simply because the less shapes, the less work. So you want to make it into as big of chunks as possible. So I'm going to put a line here and a line here. And now you see how I have 1, 2, 3 rectangles. And to find an area, right, that's what we're looking for is area. We're going to say area equals length times width. And that's going to be for all 3. So if I actually knew the length and width of these things, I could find out each one, and then I would add them all together. I would add the 3 areas together to get the area of this big cross-looking shape. And that's how you do it. So let's look at this one. You could go across here, break that down. You could break it down here. If you really wanted to get fancy, you could put a diagonal and make 2 trapezoids, but why do a trapezoid if you don't have to, right? So let's go ahead. I'm going to make my line right here. I'm going to have a larger rectangle here, and this could be a square, but since we don't have dimensions, we're going to use the basic formula of length times width because we don't know if it's actually a square or not. So length times width. And again, down here for the bigger one, area equals length times width. And if you wanted to solve for the L, you would just add those 2 together. And this last one looks interesting. What do you guys see? I could do it this way, but then what shape? That wouldn't be a trapezoid because this isn't parallel. So what I would recommend doing is breaking it across the top. You see that? Right across the top. So what 2 shapes do we have now? I think it's pretty obvious that we have a triangle up top. So remember, triangle formula is area equals 1/2 the base times the height. And then do you guys see, I'm going to highlight this. You don't, really need to highlight if you don't want to, but do you guys see this shape right here? Going here and then down, over, and back up. You guys see this shape? Wait, this shape right here is a trapezoid because this line that you made and this bottom line, they're parallel. They will never touch no matter how far you go. So those would be your two bases. Then we have our slanted sides. So they would have to give us a height, right? That dotted line height if they wanted us to find the area of this. But just so we can write the formula for a trapezoid, it's going to be 1/2 the height times the sum of the two bases. So base 1 plus base 2. And again, we would need more information to actually do this. Like we would need the height of the triangle, we would need the height of the trapezoid. But that's how you would break shapes down. Okay, now I'm going to get rid of this ink and scroll down so we can actually practice some together. Pause the video if you need to make sure you have all of this good information written down, and then we'll continue to the bottom. All right, so I'm going to clear this out. Okay, so now we're going to find the area of each composite shape below. So here, any L shape is going to be 2 rectangles, whether we break it here or if we break it here, doesn't matter. So let's go ahead and I'm going to break it. Let's do something different than we did up top. I'm going to break it this way just to show you it honestly doesn't matter. So this should be a straight line right there. And then we need to find our length and our width. So we're going to have, and this is how I want you to do it on your paper. We're going to have rectangle number 1, and we're going to have rectangle number 2, because we have 2 rectangles. So let's look. What is our length and width for rectangle number 1? That's this big one right here. So I'm going to highlight this one for you. Let's make this green, yellow green. So I have this rectangle right here. Yeah, you see that? So what are my dimensions for this rectangle? Well, it's length times width. So I can say my length is 10 and my width is 25. So that's going to be rectangle number 1. So area equals length times width. You always want to write your formula. And we're going to say that is 10 times 25. So the area of rectangle number 1 is going to be 250. You can use your calculator if you need to. 250 millimeters, that's what mm stands for, millimeters squared. Now let's look at our second triangle. Let's use blue. And our second rectangle is going to be right here. Sometimes they won't give you a piece of information and you would have to subtract. So if the whole base of this entire composite shape is 35, and I know, oops, sorry guys, I know that this piece right here is 10, you would say 35 minus 10, and that would give you the 25 left over. But it already has a 25, so we're good. And then we know that our width right here is 15. Again, you could subtract 25, which is the whole width for this, minus 10 would give me 15. So if I want to say my length, so let's go ahead and write this inside the box, and you can write it inside your picture, that's fine. So my length, we're going to make that 25, and my width is going to be 15. It doesn't matter what you make length and width because you got to multiply both of them anyway. So we have rectangle number 2, area equals length times width, which is going to be 25 times 15. Okay, and I'm going to grab my handy dandy calculator for this one. Clear this out. And I'm going to say 25, right? My length and width from down here, 25 times 15, and I get 375. So come down here. The area of my second rectangle is 375. And again, it's millimeters squared. Well, that's great. I found out 2 separate lengths, but remember, we want the area of the composite. So we want the whole thing together. So our last step is to add these two. Your last step is to say 250 plus your 375. That's your last step. Okay? So let's go to our calculator. We already have the 375. We'll add in 250. 625. So the area of the whole shape, the area of this shape, big area here, is going to be 625 millimeters squared. Do you guys see that? 625 millimeters squared. All right, let's look at this second shape right here. We have a rectangle. You guys see the rectangle? And we have a triangle with our dotted information. This is our height. That's very important. So let's go ahead. We'll do a little highlighting here. And we'll highlight our rectangle. And it gave us a little gray line. If it did not give us this, just like we drew our red line over here, you could draw a red line right there. And we have our triangle. Now this one we're going to have to do a little bit of math to find some dimensions. But let's go ahead and get started. So we have rectangle. And we don't need to label it 1 or 2 because we only have one rectangle. So we have a rectangle, which means our area is going to be length times width. So let's take care of this one first. We have our length is 3. And we can make our width 15. I did it this way because it honestly does not matter. So area equals 3 times 15. So the area of our rectangle is going to be 45. And this is centimeters squared. Okay? Now, for our triangle, so we'll put a T here for triangle, the area formula for a triangle, and please use your formula sheet. I have it memorized because I do this all the time, but if you're just learning it, you don't have it memorized. So please feel free to go back, and oh, it's got all the ink on it still, but here's your triangle up here. So go back, look at your formula sheet, find the area, and then you're going to copy it onto here. So our area is going to be 1/2 the base times the height. Remember, step 2 is to label. Well, labeling our height's pretty easy because that's 5, right? It has to be this vertical height with the dotted line. But our base is going to be from the top all the way to the bottom. To do that, we have to add some pieces because they don't give us a full base, they give us pieces. So we know this first piece is 3, the bottom piece is 3. How do we figure out what is in the middle? Well, this is a rectangle, right? Top and bottom are the same, so that means left and right are the same. Very good. So we would add up 3 plus 3 plus 3 to find our base. So I'm going to do that over here. 3 plus 3 plus 3 is going to give us our base. So 3 plus 3 is 6, plus another 3 is 9. So our base is going to be 9. You guys see how I got that? I just added up the 3 pieces because I needed the entire base of the triangle. Now we can do our formula because we've labeled all of our pieces. So we have 1/2 times the base, which is 9, times your height, which is 5. So we'll grab our handy dandy calculator, right, and clear this out. And we have 1/2 times 9 times 5. So 1 divided by 2 times 9 times 5. 22.5. So the area of our triangle is 22.5 centimeters squared. Now we're not done yet. So remember we had this 45, that was our rectangle. We have to add our 2 areas together, area plus area. So we have 45 plus 22.5. So our big area for this triangle, oh, go ahead and circle your answers because there's going to be a lot of numbers, a lot of math, especially with these little, like, what I like to call subtotals. So make sure you circle your final answer. So if we grab our calculator one last time, we're going to have 45 plus 22.5, 67.5. All right, so let's write that down. 67.5, and we're still talking centimeters squared, so we're going to put that in there. And that, my friends, is your final answer. Okay? So that's how you can find the area whenever it says what is the area. How much do you have to cover? If you want to paint the shapes, anything where you want to fill it in, that's your area. So to find the area of each composite shape, you break them into pieces and then add the separate areas up. Okay? Pause this video. Write down everything you need to write down. Okay, the next sheet we have for our notes for composite figures is just to be able to break these pieces apart. So what shapes do you see? And I want you to do it on your own. And I would like for you, you don't have to label, write the words, but I would like for you to write the formula inside the shapes or the shapes that you make. So I'm not going to make the shapes for you. I can tell you a couple different shapes I can see, and then you draw what you would like on your paper in your notebook. If I put one straight line across here, I could have 2 trapezoids. I could make 2 lines on either side, and that would give me 2 triangles and a rectangle. Again, that would be 3 shapes. When I deal with composite figures, both when I had to learn about it and when I make sheets or when I have to grade it, I want as few shapes as possible because that's just less that I have to figure out and add. So even though a trapezoid formula might be a little bit more difficult, right, with the base 1 and base 2, I would probably still break this into 2 trapezoids so that I would only have 2 formulas to solve for. This one over here, I don't see any other way of breaking it into just 2 figures. It's going to have to be a 3 figure. One, I see a great big rectangle at the top. I see a triangle at the bottom. And then if I break that, so if I put a line here and a line there, it's going to give me a rectangle in the middle. So one big rectangle, little tiny one, and then a triangle at the bottom. I suppose if you want it now, see, even if I made 2 teeny triangles, I would still have to do something here, so that wouldn't work. So I think the only way to really do this one is to make those 2 lines and make a big rectangle, a small rectangle, and then a triangle. And then I think we're pretty good on our L shapes. They're going to be 2 rectangles, so you could either draw a line here or have one long rectangle and one thicker one down here. So you make your shapes as you see them on your paper. Write the formulas. So for this one, since it's so small, if you want to write it to the side, that's fine. And then we will move on to the last paper. Okay, the last part of your notes for composite figures. I know this says an exit slip, but we're going to use this as our final example in our notes. And this gives us a bunch of information. We know the length here, we know the height of the bottom part, and we know this base. This was one that we did in the examples above on the first page, where we had this without any dimensions, and we just said, well, what shapes can we break it into? Again, you could break it into this long piece, but I'm not sure how you would figure out this area here since you don't have any bases that are parallel. So my recommendation and what I'm going to do is I am going to break it right in half. I'm going to use a line to make it look a little neater. I'm going to break it right here. Okay, so I'm going to have two shapes. I have a triangle at the top and I have a trapezoid at the bottom. To find the area, remember you break it into basic shapes, find the area of each one, and then add up your answer. So first I'm going to do the triangle at the top. So my triangle, I put a T for triangle because that's the work I'm going to do. My formula is 1/2 times the base times the height. Now I know you might not want to write the formula over and over again, but the more you write it, the better you're going to understand it, and it'll be easier to use on a test or a worksheet. So step 1 is formula, step 2 is label. What is my base? Your base of the triangle is this 13. That's the entire length down here. Your height has to be the vertical line, the line that goes straight up and down. That's your height. And that for this piece is 5. So I'm going to have, for area of my triangle, I'm going to have 1/2 times my base times my height. I'm going to grab my calculator, clear that out. 1 divided by 2 times 13 times 5. 32.5. So that's going to be the area of my triangle. Area equals 32.5, and we're talking inches in this case, so inches squared. Put a little line here because I'm going to do my next shape, which in this case, if you noticed, is a big trapezoid. I have 2 bases and 2 slanted lines. This is a trapezoid. So this is triangle. How about we put TRI? And this is a trapezoid, so we'll put TRA. That makes sense, yeah? All right, so my trapezoid formula, and you can go back to your formula sheet. 1/2 the height times the sum of the bases. Okay, so now we need to label. Well, one of my bases is already labeled, right? So we'll go ahead and call that base 1. We can call this guy down here, because it's the one that's parallel, is going to be base 2. Now be very careful. Don't use, well actually no, 15 is not the entire height. 15 is this height. So yeah, we can use 15. I was thinking we were going to have to subtract and say that this was only 10, right? Because we had our 5 up here. But the way that they have given us the information, this is 15 and this is 5. If they had only given us a 15, then the whole thing would have been 15 and we would have had to figure out something else. But this bottom part is height, so we're good. Life is good. Okay, we have our labels. Let's plug and chug. So area equals 1/2 times my height, which is 15, times the sum of my bases. So I have 13 plus 7. Again, you have to use order of operations or else it won't work. If you try and put this straight in your calculator, you're going to get the wrong answer. You got to add first. That gives us 20. And now you can multiply everything straight across. Whenever you have grouping or you have addition and multiplication, anything like that, you got to make sure you do it in order before you just go straight across. So let's grab our calculator. We're almost done, just a couple more steps. And let's find the area of my trapezoid. 1 divided by 2, 0.5 times 15 times 20. So the area of my trapezoid is 150 inches squared, 150. So area equals 150. Uh-oh, hang on. Sorry about that. Crazy neighborhood. Okay, moving on. See, now I forgot what my answer was. All right, 150. Okay. So the area of my trapezoid, see, never a dull moment in Miss Walker's life. The area of a trapezoid is 150 inches squared. Now we're not done yet. We found the area of the triangle. That's brilliant. We found the area of the trapezoid. Very good. But to find the area of the figure, we have one step left. We've got to add our two areas together. So you got to take your two answers and add them together. So to find the area of the big shape, right? Not the area of the triangle or just the trapezoid separately, but together we're going to say 32.5, that's our triangle, plus 150. So let's grab our calculator one last time and then we will be done. This obviously will not take nearly as long when you're doing it on your own and don't have to listen to me talk. 32.5 plus 150, you get 182.5. 182.5. So here we go. The area of the big trapezoid is 182.5 inches squared. And again, always circle your final answer. If it stars next to the subtotals or however you want to help yourself remember that, but the final answer for the entire figure, you want to circle that one. Well, that's all the notes for composite figures. You can practice on your worksheet, and you can watch videos for those worksheets to help you understand how to find area and how to break the multi-composite figure, multi-figures, how to break them apart and find area. Again, finding perimeter is very different. If I wanted to find perimeter, I would just add up all the sides. I wouldn't have to break it into different pieces. Okay? Have any questions, comments, or concerns? Please ask a teacher. Thanks, guys.